welcome to our next session. Happy to have here Florian. We talked together about Xenomai and real-time Linux differences within one of our community chats and so on. And so that's how I was asking. That's why I was asking about the topic to give some more insights. And of course, Jan Kiska, all the insiders anyway know, and we're collaborating since years together. Happy to have you here, giving us some deep insights into those topics in real time.
Yeah, thank you, Roger. So this is going to be a light topic right after lunch, hopefully. So it's going to be about real-time Linux with the two flavors that we are driving at Siemens. Well, not completely ourselves, but in an open source manner, and we would like to shed a light on how we are doing it, why we are doing it, and, well, when you could do what of that. So the agenda is going to look about, or refresh about your memory, or maybe just to tell you for the first time how you can do hard real-time with Linux, just briefly, not going too much into details, you know, we just had lunch. The role of one of the ways to take it there is of Xenomai. Why are we doing it at Siemens? Still or at all or whatever, why we are specifically here in a stronger position, or have to be or want to be in a stronger position than with the other alternative we'll see, Xenomai. What we are doing there to attract the community, to grow this, and what we have done the past years there. Not only us, but also our community with the help of us. And then we'll look into the other alternative, Preempt-RT. What is the importance of that, and how we are trying to help also that community for our use cases, and where we are active there. So first of all, there are two ways to do hard real-time with Linux, even today. And one of this is definitely probably known to you. This is called Preempt-RT, and this is about making the Linux kernel as it is real-time capable. Well, to be fair, it's about enabling specific code paths in the kernel, those you need normally for your real-time task, to be deterministic. Don't expect the whole kernel to be deterministic. But the idea is you are writing your application, and parts of your application, parts of the threads you have in your application, they are now able to use the Linux APIs as they are with deterministic results. So with predictable timing, with predictable behavior, obviously, as well, but not the whole kernel. You can expect to talk to certain devices and get certain events from devices deterministically, which are usually involved in the I/O communication, so field buses or general purpose I/Os or things like this, while likely your file system will not become deterministic in the same. That this is sufficiently normally sufficient for practical applications you are building with general purpose operating systems and real-time operating systems. So it's the one path, and the changes that were needed and that are now about to be mainlined, almost done by now, are, well, about increasing the preemptibility of the standard kernel. That was the major blocker over the past decades to get Linux capable of real-time. By improving the preemptibility of tasks which are not high priority by tasks which are high priority, and changing details in the kernel about. Not going to bore details here. This is the one major approach. It's not the only one, and historically, actually, this comes after the one that was used before heavily, and that's the approach to say, okay, keep Linux as it is, more or less, at least from the scaling point of view, add a specific dedicated part of the kernel for real-time, a second scheduler, therefore the term co-scheduler, which is then responsible for managing your real-time parts of your application. So again, from the user space perspective, you have an application which consists of real-time and non-real-time parts and tasks, specifically threads. But here in that case, the real-time threads are not handled by the same scheduler, they are handled by a specific one when they are in real-time mode. And to enable that, we need some dispatching now, because the normal kernel stays as it is there, but it's no longer responsible for taking all events first, but only specific ones, and possibly also those specific ones only after the critical ones have been handled. So you have a dispatching layer between your incoming events and the two schedulers. And if the Linux scheduler is running, but a high priority event comes in, then the real-time scheduler now suddenly can preempt conceptually at any point. Practically, there are certain small code paths remaining which are not preemptable, can preempt the existing Linux system and take over the control for the real-time code path. So this is the co-scheduling concept as the Xenomai project is implementing it. So what are the reasons to do this? There are a couple of them. So one of the things is actually when you're coming from a classic RTOS world or from an application stack which was not designed to work against the standard APIs of Linux, the POSIX APIs, you may have a certain baggage in your application architecture, a certain legacy, so to say, that is not easy to transfer to the new model. Then this scheduler, as it is not working as Linux is doing in all details, can help you to make this possible. It's more flexible. Linux is serving the general purpose. This scheduler can handle all the special purposes without disturbing Linux in its normal way, and enable you to add certain APIs to that. There's one reason. The other reason is with the strict separation of the two schedulers, you get something, so to say, for free. Well, there's a price for that as well. It's a strict separation of the modes you're executing in. And if a task which is running in the real-time mode suddenly triggers something in the interaction, and it can do that, like accessing the file system, which is not provided in a real-time manner, this architecture will trigger early enough for your application a signal, an information that they are leaving the golden path, so to say. Something which Preempt-RT doesn't provide in this form because its goal is to have everything unified in the same API. That can be of benefit as well if you have a large application which pulls in a lot of dependencies, and not all developers, for example, are aware of these dependencies under all constraints. That is a tool and a side effect of the strict separation. Another one of the strict separation is that under certain load conditions also this architecture provides still benefits. We will see later on some numbers on what are benefits, what are the possibilities. If you're looking for the real differences, you have to look at lower end hardware today, or you have to look into areas where it comes to high scalability, but to be honest, we rarely hit this in our devices, or into the cases where you have a highly loaded system, so where your real-time and your non-real-time workload cannot be separated between different cores but have to be co-located. There, this separate architecture helps also to get better performance numbers out of this, better latency numbers out of this. So the Xenomai project actually is a fairly old one. In 2001 it was already announced, and specifically with this one left reason, how to get from an RTOS to Linux at this time. Oops, that was the first. So it was promoted as a portability framework towards Linux. How to get my RTOS application to Linux. At that time, very popular were the RTI and the RT Linux, if you remember. Similar technical approaches for Linux, and the Xenomai project joined the RTI activity for a while. In 2005, actually, the projects diverged again. So if you know this from the past, there were the day where Xenomai and RTI was kind of the same, but then again, the project evolved on its own, while keeping also still a key asset and providing the key asset to this ecosystem that was the kernel patch that was up from that point on also shared with the RTI project, but was developed in the Xenomai project. It took a while, as you can see, until we have a new major release in 2015, which basically renovated the internals of Xenomai significantly and brought it more to a modern state at that time, and also enabled scenarios which were more and more popular at the time, so running also the RTOS portability framework over a standard kernel or a Preempt-RT kernel. And finally, where we are today now with the project, 3.2 release is the latest stable one, released last year. We have another renovation over the time, a new kernel patch that's now in and addressing the integration in the kernel a little bit smoother, a little bit more efficient. And we will also later on look a bit what's moving next in the future. So the Xenomai 4 is another generation upcoming. But what you can see on this timeline here is that it's really a long-running project. It's been in industry for more than 20 years now. It's still being used, and people are still migrating along this timeline. So if you want to watch one migration path from 2.0 to 3.x, there's a presentation about this, among other things, next week on the Xenomai community meeting. So you see that this is a typical industrial project in the sense it's being used a long while and it's being slowly evolved, but steadily. And so now the question is, how does it relate to Siemens? So we have two major usage scenarios of Xenomai inside Siemens. The one is in the area of motion control, and the other one is in the area of healthcare devices, specifically MRTs. They are using it for quite a while now, a decade by now, and they are sharing basically the benefits, or they're taking the benefits that I mentioned before, like the strict separation between the two worlds is a feature in a complex application that you can imagine that we have there. But also the minimization of certain performances if you're running on a optimized for costs processor platform while trying to achieve minimal latencies with your control application. So these are all benefits that these applications see and where they want to use it also in the future. Also the long-term support that we are building up here. So Siemens has a strong demand for that for quite a while. So it's part of our products. It's being used. We cannot simply discontinue it from one day to the other. So we have to continue working on that. Now, the situation with the Xenomai community, like with many of these industrial grade open source projects in the past 20 years, was not always that easy. So maybe you even remember the time where the RT project, the Preempt-RT project, was said like, okay, I will stop my hobby tomorrow if you don't start supporting it stronger. The Xenomai project was in a similar situation a couple of years ago, though we solved it differently. It is still a large community in the sense of how large the market is, how large the use cases are, and how many people are using it. Still, it's rather a passive community. So many people are consuming it, but not many are contributing it. And the technology itself, you can imagine, is not really trivial. So you need a certain level of expertise, core developers on the core to drive it. And if you have not many expertise or many experts working on these topics, but then you also unfortunately lose one of them, the project suddenly is in danger. And that happened around 2017, 2018. The situation even got more stressful for the project as the former maintainer and founder, Philippe Jérôme, wanted to step back from his role and focus more on technology work rather than on the maintenance work, on the evolution of the daily work, so to say. And he was looking for a successor. As I was basically contributing since 2005 to the project, I was asked as well, and also we as Siemens were asked as being one of the key contributors at that time and the key user of that apparently. So what to do now for us at Siemens? With the two major player or major user in our company, we basically could just ask them both, okay, folks, we have a problem here, we have to solve it together. So either you both decide about a migration path away from a technology, or we both decide to go into the technology and further commit to it and drive it. And short discussion, short in the sense of normal decision process in our company, but the outcome was, in the end, we decided to stay with it and to invest in it. So we got the mission to take over the role. I got the mission to take over the role. And we, as technology, got the mission also to contribute further to the project, strengthen the activity there, to compensate and further foster the evolution of the community. So currently we are about with 2 to 3 engineers involved in the project, in addition to people also working in the background on the adoption to the products. And we also invested, we will see more about it in the infrastructure of the community project, just to make it easier also to contribute to it, but also keep the quality up. And that, not that alone, but also that had a positive impact. In 2020, actually, coincidence happened that Intel joined the project, in the sense coincidence, because they came with a new group of users from Chinese market to it, but also they came to us as being a supplier to Siemens and also noticing that Siemens is using Xenomai. So they joined the project and they are still with the project, and we are happy to contribute to see new contributors here and also to see new power in the project. As I mentioned already, you can see next week on a Intel organized community meetup of Xenomai project, they also brought in this energy in the project, so very valuable. So with that, I would now hand over to Florian to talk a little bit more about further activities we had in the past years on the project.
Yeah, thanks. So some insights from the project itself. So starting with development activities. Who has ever heard of the year 2038 problem? Hands up. Oh, that's good. Who of you is serving 32-bit applications? Better. So most of you are safe. The message is the Xenomai project still cares about such applications. So we discontinued the 32-bit kernel some time ago. Don't know, 3.0 or was the last release with 32-bit?
Yeah, something like this, yeah.
And but we still care about the legacy or compat user space. So one of the problems that we have is the year 2038 problem. And this problem is not specific to Xenomai. So Linux and or at least POSIX operating systems are affected by that. Reason is quite technical. So we have a overflow in a time t data type that we have. And as Xenomai provides its own set of APIs, syscalls, we are affected as well. So we have to fix it. The kernel, or the current state, is that most of it is already done in the kernel. But you have two parts that have to work together to fix that. So you need a kernel that provides all the necessary API, and you need basically a C library or libc that uses such APIs. And the bad message is that you require glibc, or in case you're using glibc, you require quite new version, so 2.34, which is available since early this year, if I remember correctly. So this hasn't made it to distributions like Debian yet. So there's still some time for waiting, basically, because it's done, but we have to wait until it arrives. For Xenomai, this means we have to do some work at the kernel. Most of it is done. We have one data structure which has some of these affected data structures deeply nested into the API, so it will take some more time to look at that. And for user space, we have an additional challenge. So we make highly use of a linker feature which is called function wrapping to actually, say, intercept some of library calls, catch them, and route them to the real-time core. And we have to check that this kind of function wrapping still works if we tell CLib to use the non-affected APIs. As you know, there are several ways to contribute to open source projects, and it's not always about coding, it's sometimes testing. And we are operating a quite complex test infrastructure to make sure that whenever we push something into our repository, that we don't break anything. That sounds a little bit, take care so you don't break anything, but sometimes difficult to take care of all the architectures that we support, and there are so many side channels and you can't foresee all the effects that might come up, and it's very important that we just get notified about such breakages, and we use an automated CI system. In addition, as we have several parties involved in this project, the middle box is not really visible. Okay. We have 3 parties involved in that. First of all, Danks, a company which fully takes care of hosting our JIT infrastructure. So we have the Xenomai project hosted there. And we have a second project there, kind of side project, the so-called Xenomai images. The goal of this side project is actually to provide us some kind of reference images So whenever someone wants to look into Xenomai, we will likely redirect him to Xenomai images. It's a ready-to-use image which you can flash on any hardware or virtual QEMU instance, something like that, and just boot it up and everything is there. And we reuse these reference images for testing purposes also. So whenever Jan pushes something into our next or testing branch, we will trigger the CI pipelines of this project, and all the magic will happen then. So we basically have an auto-scaling Kubernetes cluster hosted at AWS, which is currently funded by Siemens. And this cluster will take care of building all these images for all the different architectures, different versions, different kernel combinations. And once that is done, we flush all these complete images to an S3 storage. And from there, the so-called Lava infrastructure will take over. So Lava is nothing that we invented. That is the tool behind kernel CI. So mostly own device testing, especially for the kernel. So we have a Lava instance located, it's publicly available. So just go to lava.xenomai.org, and we will propagate all these images to 2 different labs. One of these labs is hosted by ourselves, so Siemens. We have some machines in our labs which are regularly flashed with such images, and we make sure that they boot up, that we run the Xenomai test suite and make sure that all tests pass. And since 1 year nearly, I guess, we have a second lab, which is hosted by our friends at Intel. So they basically contribute to this project in an infrastructure manner as well. So they do coding stuff as well, but provide the infrastructure. And yeah, that helps actually, because all these test jobs takes time, and yeah, we need more boards. They could easily provide that. Cool thing. Yeah, I already told you about the quite complex text metrics. So this is for 3.2 stable, so the latest stable series that we released. We're actually supporting 3 architectures, x86 64-bit kernel, as I already told, ARM 64, sorry. Wouldn't be a new invention. We didn't invent that. Tried, but failed. We're supporting several kernel versions, more or less the Linux LTS kernels in different versions. So 4.19, which is still based on the previous iPipe patch, so one of the dependencies that Xenomai is built on. We will come to that later again. 4.4, which is the last one, which will be based on iPipe, or is based on iPipe, and 5.10, which is based on the newer patch or dependency, which is called Dovetail, so the successor of iPipe, which is or our solution for being future-proofed. Just some examples for boards that we have in our lab. So, for example, some BeagleBone Blacks for the ARM, an high keyboard for ARM64, and Siemens industrial PC, the 427E, for the x86 tests, and a lot of different targets, basically 2 or 3 targets for each architecture for doing virtual tests, because it's sometimes faster and we don't have to wait until the board is free for the next test run. Helps to minimize test efforts, or at least the time. Yeah. So next this is where are we heading to? So as Jan already mentioned, we have some in-house uses for that, so we're quite sure that our use cases won't go away overnight. So we have to support them on the long run. But as always, we have some challenges. So one of them is, for example, that the Xenomai core is slightly aging. So we have to keep up the pace with all these new upstream kernel releases. We have to make sure that it can still be integrated, that it behaves as we expected, and some architecture's limitations, like that we have limited SMP scalability. So running Xenomai on server class hardware with a lot of CPUs you might find some scalability issues to that. We probably have to clean up, so we are trying that regularly. We are shipping some kind of package with us, but we actually have no feedback if users are still using that. So we're regularly asking for feedback, but feedback is coming in not too often. We actually tried to remove the alchemy skin.
Yeah. The last resort is pulling the plug and say, I'm removing the feature. And then,
And yeah, then it's kind of magic. Some guys appear and say, oh no, I'm still using that. Please keep it. Yeah, we told you that. Please speak up. But yeah, that's life. And we have already, let's say, a next generation of simplification or renovation ahead. So that is the so-called EVL, so even less project, mainly driven by Philippe Giroum, so one of the key contributors to Xenomai. And it looks quite nice for us, so we're quite sure that we will jump on that as well. But very important for us is that we have to make sure that the migration path or the migration path is as smooth as possible. But as Jan pointed out when we showed this agenda, we still have users porting right now from 2.0 to 3 series, so we have to make sure that the transition to 4 is as smooth as possible. We are more or less prepared for that, so we make sure that everything works together with EVL right now. We are already based on the same kernel patch, which is called Dovetail, so this is already a common interface that both worlds currently already use. But of course, we have to continue testing and providing the migration path. Did I skip something? No, looks good. So, with that, we talked a lot of Xenomai, which is one of the real-time systems that we support at Siemens. My team supports, so there might be more. But there's Preempt-RT as well. I'm not audible anymore?
No.
Oh, question. Oh,
question.
It's just a question. You said you wanted to talk to the developers or to talk to the users to find out whether they use still some special features, and you only find it out once you cut it off.
Sometimes.
So yes, but I guess this is the only thing that you can do. Is there a chance to convince these people then to become maintainers for the part that they need?
We always try. I mean, as you know, also from our own environment, it's a challenge to commit to something which lasts longer than a fiscal year. And these topics usually require learning time and then a commitment time to do it. But yes, this is a continuous effort to talk to the people and explain to them what the value is. But yeah, the level to get there is remaining high due to the complexity of technology. So the goal right now is not to gain dozens of new maintainers this way, even of subsystem maintainers, or would be nice. It's more about, first of all, getting more vocal users in the sense that they are actively shaping the scope of the project, the goals of the project, the needs they have for the project, and speaking that out. So, for example, we have now a bi-weekly community call, phone call just this morning, and more people are joining. It's still a rather small crowd, but that already gives a certain kind of feedback channel regarding problems, but also regarding needs, and we try to foster this. This is a longer process, and also know a lot of these internal stories, not only since recently, how long it takes for the developers actually doing the implementation, the integration in the products, from there to convincing their management that they should contribute, that they should get involved and should speak up and even just talk about that they're using. So yeah, it's a long process, but I'm still optimistic that it's moving forward.
Yeah.
Thank you.
It's slightly getting better. So we had, for example, one of these subsystems that we have was not part of the test suite, and someone spoke up and they, hey, it's broken now. So we didn't notice. So, and now he's taking care of integrating it into the test suite so that we at least get notified when we break something. So process, but takes some time. Yeah, switching to Preempt-RT. What we see, it's not really a Preempt-RT specific topic, but internal customers are slightly sharing the vision that they want to move from dedicated real-time systems only to something that is more like a flexible platform. So placing real-time workload next to non-real-time workload on the same device, combining that with all the other Linux features that we have. We'll come to that later. And already think of opening, so traditional real-time systems are quite close, so you have one or a well-known set of real-time applications that you operate on your device, and now the customer slightly switched to, hey, what if a third party could provide such an application, and we could run and execute it on our device next to our delivered real-time applications. So openness, as we call them, is slightly becoming more important. And yeah, with that comes the important question: which platform do we use, or do we promote? Do we actually prefer, or what should we choose? And because it was overdue to several reasons, we did a low-level actually a complete set of tests for both platforms, so for Preempt-RT enabled systems and for Xenomai. This is the result of the low-level comparison that we did, because it summarizes the situation quite well. On the left side, we can see some latency measurements taken with Jitter Debugger, so an open source tool developed by our former colleague Daniel Wagner. And we ported that, or linked it against the Xenomai infrastructure, and repeated the same tests on the exactly same hardware. And these are actually the results, and you have to look closer to actually recognize a difference. So we had a 4-core CPU system here that stressed it with all kind of load that came into our mind, and let the system run for, let's say, 48 hours or something, and then just stopped the test and took the measurement results. Especially as so the system was configured in a typical Preempt-RT system configuration. So we actually isolated 2 of our cores for real-time workload, which actually means the Linux scheduler won't touch the CPUs. So only tasks are executed there which are explicitly moved to this CPUs. So no, let's say, contention from other tasks on that CPUs. And the tests from Xenomai were actually repeated with the same system or isolation configuration. On such isolated core, there isn't really a difference. So we have 6 microseconds on the microseconds on the Preempt-RT version, and we have 6 or 7 on Xenomai. So quite the same. The situation slightly changes if you look at the non-isolated cores. So Xenomai has some benefits if you're not or not allowed, or it doesn't scale, that you're able to isolate your workload CPU-wise. So if you have to collocate stress or non-real-time tasks at the same CPUs, there are some benefits. But for this specific project, we hadn't so hard requirements that we actually decided to stay with Preempt-RT for the time being, because it's the mainline solution. There's a much bigger community behind it. So why stick with Xenomai right now, or from the beginning? So we have, especially with this flexibility that the colleagues have in mind, we have a major topic here, which is resource management, because it has to migrate from something very hard or predefined and manually selected to something that is flexible or even adjustable at runtime. So we looked into several cgroups topics. So cgroups is the kernel mechanism of resource configuration in Linux. We looked into something that is called TuneD. So TuneD is a user space application we can load so-called profiles, and you can predefine a profile which actually needs or matches your real-time capabilities that you want to have. So it's able to deal with frequency scaling, which you typically disable to actually perform the CPU at the maximum speed. And I'm come to that later back, but everything that we have, so most of these APIs are there and they're usable, but sometimes it's not really convenient. So we try to make that convenient for industrial application developers as well and push everything that we have back to the upstream projects. Beside the resource management topic, we have the wish that all these real-time applications could be combined with all the remaining features or additional or other features from the Linux stack. So we looked into the so-called express data path for enabling our TSN guys for getting out the best performance for network processing. We're looking into combining real-time systems with container runtime, so big topic actually in different flavors. Some are heading Docker, Podman, OpenStack, whatever is out there, so that we might even use such Docker runtimes for deployment mechanisms, for example, that a real-time application might be deployed using such tools. Another aspect is system tuning, so we have to make sure that our system is always operating at the most possible or at the best possible performance. And we're doing a lot of regression testing, trying to follow upstream kernel releases as soon as possible, or ramping up a test infrastructure to making sure that as soon as we notice that there is a regression, that we can jump on it and at least report it, better debug it, or at best solve it. And all that, especially the system tuning, and we're trying to do in a easy to reuse manner. So we have we're using our ISAR build system or ISAR build system again, and doing that in an inner source collaboration project where all the different projects come together and actually make sure that we can reapply the tuning to all the different platforms that the projects are targeting. That's not open source yet, but at least inner source. Here, we don't stay, or we try to not stay behind our Siemens walls. So we try to contribute as much as we can in two major Linux Foundation hosted projects. So one of them is the Preempt-RT project. As already mentioned, that didn't happen so much so far. So we are currently trying to ramp up ourselves to be prepared once the customer comes back with problems, so that we are in a state that we can contribute with the community, that we are already known to them, and especially that we have working regression reporting or regression testing infrastructure available. The infrastructure may look identical to the Xenomai infrastructure, so because we have on-device tests that we need, and for now it looks that we could heavily reuse that. And last but not least, we have financial support for this project, so we're funding it. And the TuneT improvements that are mentioned here is that we found some, especially I guess Adrian was it, also part of the audience, so thanks for that. Found some improvements that enabled us to simplify or improve our system tuning using this tool, and all this is moved upstream so far, so we simply can reuse later. Second project is the civil infrastructure platform. Once again, we have the financial support, but even more important is that we, at least Jan, is actively taking part in the so-called super long-term support for kernel. So in addition to that, what upstream already provides with the stable kernel series, we're having much longer intervals of support for that. So, and with that, it's time to hand over to Mr. Linux again.
Who? Yeah, to summarize our presentation, so as usual, no one size fits it all, although we will love to see it like this. The simple answer to what Linux, what real-time Linux to choose is, okay, for common cases, Preempt-RT is generally fine. So choose it as the first default. If you see special needs, if you see, or if you have special demands, if you are actually about these, what's happening here? Someone wants me to stop here. If you're actually about seeing this corner cases, maybe Xenomai is an option for you. So that is basically the story in short. For us at Siemens, it's important that we are committed to both technologies and we are driving both to our needs and our possibilities. We are maintaining and evolving further Xenomai. We are sponsoring Preempt-RT. We also want to be more part of the community than we are so far. So we are working on this. We are contributing requirements and codes more and more, and obviously also try to improve the testing infrastructure where we see gaps or where we would be able to help out with some topics. So yeah, and with that, I would say thank you for your attention, and we will open for further questions. Thank you.
I have one question. How long does it take to really become kind of a real-time Linux hacker as you did? I guess if you look at the things, let's say you see the web or some cloud technologies, a lot of people get familiar quite fast with all those things. But to me, it looks a bit like in the real-time domain, you need long experience.
So if you ask me, the answer is maybe 20 years. Because this is where I started, but maybe you should ask Florian for that, because he's a little bit fresher on that topic.
Too fresh. Don't know how long it will take.
But honestly, yeah. As you have with complex systems, and these systems are also complex, although they are on a lower level complex, you run into complex problems, and you sometimes don't see where things are coming from. So you see weird issues, timing issues, which we just have one issue, not to mention the product line, which happens unfortunately in the field every other week on still too many devices, and we currently have no clue how to get to the point. That is where the fun starts. And then you hack, like Florian, the past weeks out of the hell, out of a certain test case in the lab, you find something which was a different problem. And this is where the frustration starts, and where you start to, okay, I have to understand a lot of details now just to find out, yeah, that was the wrong pass. It's still a bug, but it's not the one that I was looking for.
Yeah.
Thank you. So yeah, I mean, the technology is special, but in general, the approach, I think, if you are debugging a complex distributed cloud system, or if you're debugging a complex, also distributed real-time system, but just in a small box, it's not that different from a approach, hopefully, but it's different from technology you're facing and from how close you get to the hardware, maybe also.
Yeah, maybe that is the right place to notice that we're still hiring. So if someone is interested in such topics, we're growing.
Also kernel engineers.
I have a question. So you mentioned that, you mentioned that you are now the main maintainer. So I wanted to ask, from the open source perspective, like how is it since you became the maintainer, and hard and experienced tips for whoever might get into this position in the future? Not talking about me.
This is a good question. I think also there are maintainers and maintainers. If you are basically maintaining your just created own project, that's a different thing than when you're taking over an existing thing. And if it's also a different thing if you're taking over the Linux kernel, which I'm not planning to do, from a complexity point of view, or here a rather specialized community with also a well-established network with its own challenges. The major challenge I see as a maintainer is that it's not like as you think in management, okay, I'm now away from technology, whoops. I can lean back and just say, okay, yes, no, yes, no. You still have to follow the development. And the more you have to follow the things in technical details as a maintainer and decide about things, while no longer being able to do all the stuff, the harder it gets. It means in turn, you have to stay on the topic in some areas, or you have to yourself have a harder time to pick up again. On the other hand, what I experience, I'm not maintaining only this project, a couple of more by now, some of them chosen, others, gained. You also experience at the time a certain workflows. So you're accommodating to that. So things come in out of surprise. I have to decide, either I push it away or I try to approach someone. I try to pull in people and ask others for that. And these patterns also get more to regular routine, and that helps also. But it's a managing task, but also a technical task, which is interesting and challenging at the same time. So I enjoyed it a lot, but it's also challenging if you have to do other things as well.
So we're coming to an end. Thank you so much, Jan and Florian, for providing us all those insights and for working on those topics for years with such a deep expertise. And yeah, I hope we'll find some new colleagues for Jan and Florian. Hey, apply now and see you.